think that we all live in a beautiful world, and I am sure that you all can agree with me. Every once in a while, I see something that reminds me of this. And recently, NASA released photos of the Earth taken from afar. And you can see us there, just over the horizon of Saturn, this beautiful blue glowing dot. And you can't help but to realize how unique we are and how beautiful this planet is. And we as human beings are stewards of this planet. And tonight I'm going to share with you a way that we can become better stewards. Because basically right now, we're not doing so well. We know that through fossil fuel burning, we are emitting a lot of greenhouse gases. Specifically, carbon dioxide has accumulated to levels in our atmosphere like we have never before seen. And it's simple, really. Matter is never created or destroyed. And so if you pull carbon out of the ground and you burn it, you release it into the atmosphere. And if things on our terrestrial Earth, like photosynthesizing plants, cannot take up this carbon dioxide quickly enough, then it stays in our atmosphere or it's sinked into our oceans. And when carbon dioxide enters our oceans, it causes acidification. And our animals can't really handle that acidification. And so this risks entire food webs in our oceans. When it's maintained in our atmosphere, it causes a warming effect, which leads to ice cap melting and extreme weather events. So this is big, but this is not our only problem. We also generate a lot of trash. Currently, landfills like this all over the planet have already been filled up and capped off or are very close to being full. And if you go to a capped over landfill and you dig deep down into the landfill and you take out a core sample, you find completely intact trash. And so this stuff isn't going anywhere very quickly, and it's definitely not going away at the rate that we're making it. We also have transformed a lot of our pristine forest lands and jungles into agricultural fields. And while we're working to maximize the productivity of these fields, they just aren't cutting it. Currently, 38% of the world's surface is covered in agriculture. Not the world's surface, but the world's terrestrial surface. And yet still, 1 in 7 people on our planet is considered to be food insecure, meaning that they are either currently hungry or they are living in real fear of starvation. So when you look at all these problems on a global scale, they only get exacerbated. In less than 40 years from now, in 2050, our world population is expected to hit 9 billion. That's billions of more mouths to feed, billions of more people demanding energy, and billions of more people producing trash. So from the global scale, it's overwhelming. It feels hopeless. But what if I were to tell you that this material offers some promise to mitigate all of these problems? This is biochar. And this has received an intense amount of attention in the past decade from scientists. But there's absolutely nothing new about this idea. Thousands of years ago, we believe that native Amazonians had a waste disposal practice by which they dug deep earth pits. Into the pits, they threw their agricultural residues, their food scraps, even their broken pottery, and then they lit that material on fire. After that, they covered the burning material with soils. And so this created conditions with very high heat and very low levels of oxygen. And so rather than that carbon in the material being released and fully oxidized as carbon dioxide, it actually stays right there in the soils. And today we find evidence of this. If you look into a typical Amazonian soil, you find very light-colored soils. They're very low in nutrients, very low in organic matter, and they're acidic. And so what this translates to is very poor soils for crop production. Often farmers will clear an entire area of forest through burning in order to cultivate that land. And then that soil only supports crop growth for a few rotations. And then they have to pick up and move it to do the whole process over again. However, nested within these infertile soils, we find deep, rich earths called terra preta. So terra preta is not like any of the surrounding soils. It's very dark in color. It's high in organic matter. It doesn't have nutrient loss or leaching, so it supports crop growth for much longer. And it's not acidic. When we look closely into terra preta soils to see what makes them different, we find charcoal. If you use a high-powered microscope to look at charcoal, you see that it's covered in these microscopic pores. And it's also a very, very dense version of carbon. And so what this means is that these charcoal materials are acting like a sponge in the soil. They're helping soils to hold on to various nutrients, and they're also helping to improve the overall structure of the soil. So a simple practice used by native Amazonians improved their soil fertility for thousands and thousands of years. And we think that we can modernize this process. So if you come to present day and you have some sort of organic waste material, that could be agricultural residue or food scraps, anything from peanut shells to peach pits to wood packing crates. You can take that material and put it through a process called pyrolysis. And again, that's heating materials with very high heat and very limited levels of oxygen. When you pyrolyze the material, you generate biochar. And biochar sequesters approximately 50% of the source carbon. If you were to allow the same material to decompose, you would be left with compost. And that compost, after about 5 to 10 years, only sequesters 10 to 20% of the source carbon. And if you did slash and burn agriculture and burned off those residues, you would be left with a fine ash, and you've only sequestered 3% of the source carbon. So if you take your biochar and you add it back into the soil, it can stay in soils for thousands of years. So it's sort of serving as a stable carbon sink in our terrestrial land. Furthermore, if we were to produce biochar on a global scale from all organic waste residues, we could produce man-made carbon dioxide carbon equivalents by 12% annually. So this makes a huge dent in the carbon dioxide that we're outputting. Not only this, but when you're adding the biochar into the soil, you're improving the soil fertility. And I'll use our local soils as an example. Here in Riverside, when we amend our local soil with biochar, we increase the soil water holding capacity. And when we increase the water holding capacity, we can reduce our irrigation inputs. And this means water savings. And we all know how important it is to save water in our region. We also lower the soil bulk density. So this is important because when soils are compacted, it's more difficult for roots to grow through them. And when soils are less dense, we call these soils well-structured. And so roots move easily through the soil, and that translates to larger root mass. And what you see below ground translates to what you see above ground. So when you have dense, healthy root systems, you also have healthy plants and higher plant yield. We've seen this in our lab. When we amend our local soils with biochar, we had 90% larger cucumber plants than when we planted the same seeds in non-amended soil. So it's important to share with you that biochar is not a single material. It is actually an array of materials, and the chemical and physical properties of biochar are different depending on what you make it from and how you make it. But that's why research like what we're doing here at UCR is so important. In fact, the community gardeners here at UCR have gotten involved. Biochar fits right in line with their mission of sustainability. And they're looking at biochar on a field-wide scale and testing it with various types of crops. And it's not just UCR. Biochar has become an entire movement, and it's gaining momentum. In the last decade, we've seen international societies built and dedicated around this topic. We have databases characterizing different types of biochar being put out by major academic institutions. And products are popping up all over the market. You can even buy biochar at Whole Foods. And you can go on YouTube, and you can look up videos for how to make a piece of pyrolysis equipment that allows you to take your own yard waste and and heat it with low levels of oxygen. So in your tote bags, you have biochar. You have a little packet of biochar here, and this packet is enough biochar to amend a pot of soil this size. And so today I'm challenging you to become a part of just one solution that helps us to become better stewards for our planet. Thank you.